morning, students. I'm Krishna Rao, Assistant Professor in CSC Department, Institute of Aeronautical Engineering. I'm handling compiled edition. So, today we'll discuss the ambiguity and also eliminating the ambiguity from Dangling else grammar, if else statements. So, we discuss the elimination of the ambiguity from if-else statements. Parse tree is the graphical representation for a derivation, right? So a derivation for a given derivation, the graphical representation is referred as a parse tree. It filters out choice regarding replacement order. So the derivation steps will be specified in the derivation tree or parse tree. The root by the start symbol S. The root of the graphical representation will be represented as S. The interior nodes represent non-terminals in N. So the root of the parse tree is S. And the non-terminals are represented as a interior nodes. The leaf nodes are the terminals are simply empty symbol. Right? The terminals are represented as the leaves of the graphical tree. Right? So node A can have children x1 to xn if the rule A equal to x1 to xn. Right? So if there is a projection A gives x1, x2 to xn, then we consider its A node non-terminal will have a children x1 to xn. Right? So a parse tree is a graphical representation of the derivation. S is considered as root of the tree and all interior nodes are represent non-terminals in N. Right? So the interior nodes are represent non-terminals in N. Then leaf nodes are the terminals in T. Right? So if there is a projection A gives x1, x2 to xn, then we consider a node have a children x1 to x2. So we are considering an example. E gives E into E as a projection. Right? E gives E into E as a projection. Then it is a graphical representation as E gives E into E. Right? The projection E gives E into E, we are representing in the parse tree E gives E into E. We are expanding that as E gives E plus E into E. So here the root representing the expression E into E, then E gives E plus, right? E plus E into E, right? The derivation of this string is represented here, right? Then that E is represented with the ID. Same we are representing here. E equals representing as ID. Then the second one E also replaced with ID. So the second E also representing with ID. Right? Second E also representing with ID. E equal to ID plus ID into ID. Right? So here the third expression also replaced with ID. Right? This is a ID. The root will be the starting symbol E, and all the interior nodes are the non-terminals. We have only one non-terminal E itself. So all the interior nodes we are representing as E, and the leaves will represent the terminals. The leaves are representing the terminals ID, ID, ID. So these are the leaves which are the non-terminals, which are the terminals. Right? So this is the given final parse tree. Right? So in a parse tree, all leaf nodes are terminals. In a parse tree, all these leaf nodes are the terminals. All the interior nodes are non-terminals. All interior nodes are non-terminals. Right? All interior nodes are non-terminals. In-order traversal gives original input string. In-order traversal. So ID plus ID into ID. The in-order traversal gives the original input string. Right? The leaves of a parse tree are read from left to right, called the frontier or yield of the tree. Right? So the leaves of the parse tree, when read left to right, are called the frontier or yield of the tree. Right? A parse tree depicts associativity and also precedence of operators. Right? It will consider associativity and precedence of operators. The deepest subtree is traversed first, therefore the operator in the subtree gets precedence over the operator which in the parent node. Is it clear? So here the deepest subtree is traversed first. Therefore, the operator in the subtree gets precedence over the operator which in the parent nodes. A grammar is said to be ambiguous if it has more than one leftmost derivations or more than one rightmost derivations for the same string, then we say the grammar is ambiguous. Then we say the grammar is ambiguous. Right? A grammar is said to be ambiguous if it permits a terminal string to have more than one parse string, more than one leftmost derivation, or more than one rightmost derivation for the same string, then we say the grammar is ambiguity. Right? There must be two leftmost derivations or two rightmost derivations, then we say the grammar is ambiguity. If the grammar is not ambiguous, then it is called unambiguous. If the grammar is not ambiguous, then we say the grammar is unambiguous. Now, an example is given. A, S, B, or S, S, or epsilon. The string A, B, B. Now we want to check the grammar is ambiguous grammar or unambiguous. What we say, it has more than two leftmost derivations, or if it has more than two rightmost derivations, then we say it is ambiguity. What is the leftmost derivation? Always replace the left and non-terminal with its production. What is the rightmost derivation? Always replace right and variable, right and non-terminal with its respect to production. Okay. Now, first we are saying as S as ASB. Then the ASB giving as once again ASB production. Production 1 we have selected. Once again production 1 we have selected. Then we have selected the third production. So the derivation tree follows applying production 1, then production 1, then production 3. Second one. What is we have selected? S equal to derived SS. The second production we have selected. We have selected the second production. Right? Executes SS. The second production we have considered. If then we have selected third production, right, which implies third production. We are following leftmost derivation, right? We are following leftmost derivation. We always replace left and variables, right? So here first we applied second production, then we applied third production, right? So excuse ASP. Excuse ASP. Now, what is the production we have selected? The first production we have selected. First, second production, then third production, then first production. Then finally, once again, we are applying the first production. Then we are applying the third production, resulting epsilon A epsilon BB results to A B. Right? Here we are always replacing leftmost non-terminals only. Left and non-terminals only. But there are two leftmost derivations. Then we say the grammar is ambiguity. Then we say the grammar is ambiguity. More than one leftmost derivation. So the grammar is ambiguous. So one more example. This given grammar is ambiguous or not. Now we are considering ID plus ID into ID. Now, E gives E plus E production number 1 we have considered. Then E gives ID, leftmost derivation we are using, right? Leftmost derivation E gives ID. So production number 3 is considered. Then E gives E into E. So second production considered. Right? Then second production is considered. Then E gives ID. Third production is considered. Then E gives ID once again. Third production is considered. So finally we obtained the given terminal string ID plus ID into ID by considering the 1, 3, 2, 3, 3 order of apply. Okay. This is another leftmost derivation. Now, what is the order we have followed? First, we have selected the production number 2. We have selected the production number 2. E gives E into E. Then we applied production number 1. We applied production number 1. E plus E. Right? E into E is the first we applied. Then E plus E. Then we applied third one. E gives ID for this one. Third one. This is the first one. This is the second one. After that, we once again we applied third production. Then once again third production. 2, 1, 3, 3, 3 is the order of applying the productions in the deriving the given string in leftmost derivation. If you observe, the first one order of applying the productions and the second one order of applying the productions is different. In the both one, we are applying the same leftmost derivation only, but there are two derivations. Then we say the grammar is ambiguous. Right? Simply we conclude the grammar is ambiguous. Two leftmost derivations possible, so ambiguous grammar. Ambiguous grammar should be avoided. Do not guarantee unique parsing and translation. If there are more than one ambiguous grammars, then we cannot have unique parsing methods and translation. Expression evaluation is not clearly defined in the above grammar. If the grammar has ambiguity, then it is not good for compiler construction. It is not properly constructed the compiler. So no method can automatically detect and remove the ambiguity. But it can be removed by rewriting the whole grammar without ambiguity. So by rewriting the complete grammar, we can eliminate the ambiguity. Now, consider the following grammar. Show that it is ambiguous grammar. This is the if, then, else statements. Right? The statement is given if expression, then statement. If expression, then statement, else statement means if then else, and any other statements. Now, the example it is given if expression 1, then if expression 2, then S1, else S2. Now, we want to match the non-terminals. We have to derive a parse tree for this non-terminals. Now, the statement gives if expression, then statement. So, 1 is applied. Then, the statement once again giving if expression, then statement, else statement. So, 2 is applied. First production is applied, then second production is applied. If we consider this one, first, second is applied. If, else, if expression, then statement, else statement S2. Then, it considered if statement 1. So, order we have considered 2 and 1. Okay. Second order, the first order. Second order, second statement we have considered. First, if expression, then statements, else statement. Then we have selected first one. For given statement, there are two parse trees, 1 and 2, 2 and 1. The two parse trees translates differently the else part. The two parse trees translate the else part differently. Right? The else part can be attached to inner if, should be the case, or to outer if. So that is the problem in this if else statements. Right? We'll discuss how to remove that ambiguity. So show that one of the practice problem. Show that the following grammars ambiguous or not. Right? Show that the following grammars are ambiguous or not. Now, the ambiguous grammar for expressions. So what we have discussed earlier, there is no direct method to eliminate the ambiguity in the grammar. That ambiguity can be eliminated by rewriting the productions so that we can results unambiguous grammars. Right? The best method, rewrite the productions to get unambiguous grammars. Right? So to handle ambiguity in the expressions, the precedence and associativity of operators specify order of evaluation. Right? So to handle ambiguity in the expressions, we will consider the precedence and associativity of the operators to specify the order of evaluation. Right? Higher precedence operators are evaluated first. Higher precedence operators are evaluated first. So equal precedence operators are evaluated according to their associativity. Some operators are left to right associativity. Some operators are right to left associativity. Right? Some operators left to right associativity. Some operators are right to left associativity. So here we consider the associativity for the operator which have equal precedence. So to handle the precedence of the operator, divide operators into group of equal precedence. So divide the operators in the group of equal precedence. For each precedence level, introduce a non-terminal and grammar rules, each of which represent those expressions that share a level of binding strength. Right? So we introduce a non-terminals and grammar rules in rewriting the productions such that the ambiguity can be eliminated. Right? Design grammar rules to be either left or right recursive. Right? Now, we are considering a word factor. A non-terminal f is an expression that cannot be broken apart by an adjacent operator, either a multiplication or a addition. The only factors in the expression languages are identifies, expression. Right? It is not possible to separate the letters of an identifier by attaching an operator, similarly number. An parenthesized expression, no matter that appears in the parenthesis, it is purpose of the parenthesis to prevent what is inside from becoming the operand of any operator outside the parentheses, right? So we are considering that f as id, a number, or parenthesized expression, right? Then we are introducing term. Term is an expression that cannot be broken by the addition or subtraction operator. Here, operators are plus, minus, and multiplication and division operators. A term is a product or division of one or more factors. Right? Term is a product of a product or division of one or more factors. For instance, A into B can be broken if we use left associativity and place A1 into its left. That is A1 into A into B as grouped as A1 into A into B, which breaks apart the A into B. So, however, placing additive terms such as A1 plus to its left or right to its right cannot break A plus B. The proper grouping of A plus A into B is A plus parenthesize A into B. And the proper grouping of here A into B plus A1 is A into B plus A1. So we are considering as the term is for the multiplication and division operators of the factors. Then an expression. So an expression will be considered as the either adjacent, addition, subtraction. Right? It cannot be broken by either an adjacent multiplication division or an adjacent additional subtraction. So thus an expression is a additional subtraction of one or more terms. So the ambiguous grammar is now E plus T or E minus T slash T. What is the term? Consists of multiplication and division of the factors. What are the factors? Identifies, numbers, parenthesize, expressions. So, the ambiguity grammar is rewritten such that by considering the new non-terminals and productions, we are converting to an ambiguous grammar. So, we are converting to an ambiguous grammar. So here expression giving E plus T, then expression giving term, term giving the factor, factor giving the identifier. Then term giving term into factor, term gives factor, the factor gives ID. F gives ID. So E gives E plus T, T plus T, F plus T, ID plus T. Then T gives this T as T into F into F, ID into F. Then finally F equal to ID. So that is the derivation of the string or parse tree for ID plus ID into ID. Now consider the following grammar once again. That is a ambiguous. So previously we have checked that the if expression then statement, if expression then statement, else statement is ambiguous, where they are resulting two derivations. First followed by two here, first production followed by second production. Here there is a second production followed by first production, right? For the same given example, if expression, then if expression, then S1, else S2. For this dangling else, there are two derivations, right? So we saying it as ambiguous. Two past states are possible for the sentence, right? If E1, then if E2, else S1, else S2. The two past states, the two past states translate differently the else part. The two past states translate differently the else part. The else part can be attached to inner if. The else part can be attached to inner if. Should be the case or to outer if. Right? The two past trees translate differently the else part. Right? The else part can be attached to inner if that should be considered. Or it might be outer if. Okay? In general rule, in the general rule, match each else with the previous, the closest if then. Right? In general, we specify that match the else statement with the previous closest if then statement. Right? To eliminate ambiguity of else in if statements, distinguish matched if statements from unmatched ones. Now we are introducing two terms, matched if, unmatched if. Insist on having matched statement between then and else. Right? Matched statement, there should be a complete sentence if else. If then else. Unmatched means it might be if then only. Right? Insists on having a matched statement between the then and else. There should be a matched statement between then and else. So what is a matched statement? Here, either an if then else statement containing no unmatched statements. Either an if then else statement, either an if then else statement containing no unmatched statements, or any statement which is not an if then else statement and not an if then statement. Right? It considered as a matched statement. Then what is a unmatched statement? An if then statement which is no else part is say as unmatched statement. Matched statements it should have if then else. It is a matched statement. Unmatched statement means an simple single if then statement with no else part. An if then else statement where unmatched statements are allowed in the else part but not in the then part. Right? So here any else statement it should be matched. Any unmatched statements are allowed in the else part only, not in the then part. The then part must have only the matched statements as in specified in A. Right? So, to eliminate the ambiguity in the else if statements, we have included two terms. What are the two terms? Matched statement, unmatched statement. Matched statement means which has if then else completely. Right? If then else statement completely. Unmatched statement means there is no else part, only consists if then statements. Any unmatched statement are only allowed in the else part only. The then part must be completely matched one only. right? Now we are rewriting the dangling else if statements, right? We are rewriting the production rules with the new terms matched statement and unmatched statement, right? So the statement will result a match statement or unmatched statement. A statement will result a match statement or unmatched statement. So match statement is if expression, then match statement, else match statement or other. Okay. So match statement equal to if expression, then match statement, else match statement or other. Unmatched statement, it will consist only if expression, then statement, right? And if any unmatched statement, that is allowed in else part only. If you observe, if expression, then part must be matched statement. Else part may have unmatched statement, right? It must be, then part must be a matched statement. Else part may have unmatched statement. What is unmatched statement? Simply if then. What is a matched statement? If then else. That is a matched, this is a unmatched. If then is an unmatched statement, right? Here in this unmatched statement also, the then part must be a matched one, the else part may have unmatched statements, right? Statement, if expression statement, the statement might be result if expression match statement, else matched statement. If expression match statement, else match statement. So the match statement be S1 or it might be S2, right? So by rewriting the expression statements, we are eliminating the ambiguity in the grammar. So we are adding it two terms, matched statement and unmatched statement. By including these two new terms, we are eliminating in the ambiguity in the else in F statements. Now, if expression, then statement. Then the statement, we have a complete if then else. Okay. So first statement is we considered the unmatched statement. The unmatched statement, the then part considered complete if then else statement. A matched statement. Here, this is given as if expression then statement, if the expression then statement, else statement, which is not. Because the then statement is unmatched. Is unmatched. Right? Here, the then statement must be matched statement, else unmatched. Simply then is matched statement, else matched statement. Right? Simply other statement. Right? So this else part is must be considered for nearest to them. The else part is considered to match with the nearest unmatched if then statement. statements, right? Any else statement, it is an input that must be considered as a else for the nearest unmatched statement, right? So here it once again accepted form, if then else statement. So a statement equal to if expression then statement else statement. The statement once again have if expression then statement else statement. So here both are a matched statements, right? Statement applying the match statement. Once again that else statement is once again having a match statement. So by rewriting the given grammar, if expression then statement, or if expression then statement else statement other, the given grammar is rewriting in this form statement equal to match statement or unmatched. The match statement is should have if then else. Both then and else should be have match statements. Unmatched statement, it might be if expression then statement, right? It will have if and then only, right? So here are if expression then match statement else unmatched statement. So rewriting the given grammar, we can eliminate the ambiguity in the grammar, right? So unmatched statement having a matched statement which is unambiguous. So with this one, I'm closing this section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.